Hey, how's it going? How are we all doing? It's Wednesday. I was gonna capes, but then I've seen a lot of people playing the farmer. The farmer was replaced, and I've been getting very angry at some of the code that's being written. And I'm not a fan of Python, but it some of the code I've seen makes me very angry. So I thought, you know what? I'll see if I can do it better. If you haven't seen this game, the farmer was replaced. We basically are automating a drone to farm for us. So we can move windows around. This is our. I'd hate your code. Yeah, we'll see. So we're gonna get started. First programming. So we click this. We can start. We can step through. Code can be edited like it's not running. When you run a pair of flashes, you can create more code files by pressing the plus button. So we can create those. Code completion. So we can go do a flip. And then we can go and get it to do a flip. We can tab through, and I've got tab set to one of the good options in this somewhere. Tabs to spaces. That's very nice, and you can put stuff in an external file. Don't worry if it's not your first time programming. Languages don't unlock step by step. Syntax is similar to Python, so if you already know Python, it's fine. You'll be able to get stuff going mostly all right. I mostly know Python. I don't use it a lot, but I know enough to be dangerous. So we can harvest. Oop, keyboard's not where I expect it to be. So we can harvest. And we can. So what can we get with unlocks? So unlocks here. So we've got loops, speed, grass, plants. So these are all things that we'll have to eventually unlock. Carrots, trees, cactuses. I don't know what polyculture is all about. Use companion planting to increase the yield. Okay. And then a leaderboard. And this is in early access. This is in early access. So how do I get back out of this? Oh, farm. So he's using like API, UI, and a bit of assembly, but spaghetti Python is definitely something I'm good at. Yeah, you can write bad Python. You can write bad Python very easily. So we've unlocked loops. So we can just say here, hey, word notify, while true, harvest. And that will just keep harvesting for us. So now we are racking up. We are racking up our hay bales here. And this is sort of teaching you can, while true, or, you know, you indent. The indenting thing. Indenting is my bane in Python. So let's stop this because we've probably got enough. So let's unlock speed so you just run faster. But now because it's running faster, it's harvesting, but it's not actually grown. Can I if? Delete that. Can I? Oh, right. Okay, so you can't do that yet. So do you have to like if can harvest. If can harvest, then harvest. Am I allowed to do this? Yeah. There we go. So now I can check whether I can harvest or not. Yeah, so we've got... there we go. This is what this is saying. White space, Python, which is more obvious? Python, white. I would always go with parentheses, with some sort of bracket. Just because you can match them up, but if they're like actual parentheses like this, then it's less good. I can never remember though if Python has a switch statement. So let's unlock grass. So external editor, this is, yeah, your external editor, available functions. So we've just unlocked grass. Oh, that just increases the yield of grass. Okay. Python has break. Yeah, but Python, like, if I start writing... So if I start writing something here, that's still in the if. But if I'm there, that's out of the if. Which is so annoying. In fact, that might still be in the if. But if I write something here, that's no longer in the if. It's frustrating because it's not easy to see. So let's unlock planting. Grass is nice because it grows automatically. All other plants have to be planted with the plant function. The only plant you can plant right now is a bush. You can pass the type of plant you want to plant to the function like this. Entities bush. And it would throw an error. So you can plant a bush. So let's stop this. And let's say... Let's just get rid of this and let's plant a bush. Entities.bush. So we've got a bush there. So what we can say is, so we plant a bush, and then while not can harvest, do a flip, and then we say harvest. And then we just say here while true that. Nope, shouldn't be a colon there. Unlocks.operators have to be used for this. Where is that? It's down there. This is lets me move. You only cost 30. Can I comment this out with control? So let's actually just go comment this out. And what I'm gonna do is say, in fact, actually, nope. Let's just do this. I need to while can harvest. equals false. I can't even do that. Fine, we'll just do this for a minute. Yeah, that's not gonna last long enough. Yeah, I didn't want to do an if else. So let's start. It's just because I haven't got not unlocked. So let's say while true, we plant entities.bush, then we move north, and then we say if can harvest harvest. So this will just throw us there until we get there, and then it'll just keep running north. One nice thing about this is that it wraps around, so you're not stuck at the bottom. So we're unlocking those. We'll unlock. I need 200 for that. I need 30 for operators because we can do this better. Oh, you need like 300. So what I might do, let's stick this and let's call this plant bush. And this can be plant underscore bush. This is my function, plant bush. Let's stop you. And yep. Oh, you need functions to do this. Where is functions? Functions is right down there. Okay, so we can't do that yet. So we're gonna have to keep doing this. Can I available functions? Harvest, can harvest, plant, move, do a flip, clear. We haven't got sensors yet, so I need to plant. Let's delete that. I need to get rid of that. Yeah, by the time I come to use it, I will probably want to get rid of it. So actually, we need to get more hay. So we'll unlock sensors. So now we can get the position and the Y position. We can get the number of items, so we can check how much of a particular type we have. We can get the ground type and the entity type. So we can do things like, oh, we've also got none. So yeah, if there's nothing, it returns none. So we just need more of that, and then we can unlock. How do we make our farm bigger? It's a new window. Where is it? Expanding. Your farm has range, function get world size. This is fine. How do I expand the farm though? Oh, right, I can redo these. I can do these multiple times. So if I want to expand again, I need carrots. Right, so now I've unlocked operators. So I can use plus, minus, equals, boolean, add, subtract, and so on and so forth. I can do modulus. I can do power. That's double star. I can do less than or equals. So what I can say is right. Let's just. Oh, and we've got more. We've got more of this now. How do I get to functions? I need to get variables and carrots. So I do need to get carrots. So what we need to do? Let's think about this. So you are going to be plant grass, and this is simply if can harvest, if can harvest, then harvest. There's a thing about plants. Yeah. There's something around checking what the ground type is. Get entity type, get ground type. If I do get ground type here. Get ground underscore type. Yeah, it doesn't actually know. What if I go plant entities dot bush? Oh, can I print this? Hang on. I haven't got the debug. So what I could do here, just to, I can actually plant grass. And then we say if can harvest, then harvest. So if we can harvest, then we plant entities.bush. So this is planting bush. So now we say if num items dot hey is less than or equal to, let's say, 500, then you know what, I'm actually gonna change you back to change you to tabs. So then we say else if norm underscore items dot wood center equal to 500. Then we plant a bush. Do not mix tabs and spaces. Oh, let's clear these into sort this out. So because hay is less than 500, so let's just grab this and save this. So what I need to do now is, so you are my plant checker. This is traverse. This is traverse grid. So I can say so basically we want to go north. So have I got variables? No, I don't have variables yet. Basically I want to say I always want to move north. If get underscore position y equals get world size -1 because it's 0 offset, then we move east, else move north. What is the command to unindent? Shift tab. Let's say no, it needs to be, let's say, alt tab. No, that's not good. Control tab. I'm probably gonna forget that. Oh, you need to be east. So you go there, and then you go to there. So this traverses the grid. So this is going to traverse the grid. So what we can do is we can grab our traverse code and put this here. And then we can say plant items. And then we indent this and stick a while true And what we probably don't even need to bother doing is that. So let's change this to like 300 and 300. So we just leave it going and it should grab a bunch of this. Can I move? I can move all three of those at once. That's quite nice. So we've got 300 there. So we're now planting wood. So now let's, because we need it, when we get to 100, we need to unlock carrots. I don't need debugging. I'm all right with debugging. What do we need for that? 50 carrots. Let's get this faster. Okay, let's move these out of the way here. And how did I stick you to that? Ah. So dropping the window on it. Let's move this over here and this to here. Right, so you can now unlock carrots. So before you plant carrots with plant, you have to do two new things. First, they only grow on tilled soil, so you have to till it. And then the next is that they need seeds, so you can trade seeds, and you buy them. Okay. So let's just call this my playground. So if, let's say, so the first thing we need to do is buy carrot seeds. So if items.carrot seed is less than, say, 10, then trade items.carrot seed. How many do you buy? I don't have multi-trade. I don't know how you unlock multi-trade. Oh, it's there. So we're just gonna buy one seed. Let's buy like in fact, let's not do that. Let's say while okay. So that buys us our carrot seeds. Then we will till. If can harvest. I don't think we need to, actually. so we till the ground first, then we plant carrots. So we plant entities.carrots. Let's say if can harvest then we harvest. So if we can harvest, then we harvest. Otherwise, but regardless, or do we then till and then plant? If we go while true here, so you're just waiting. Let's just make sure we can see that we're doing something. So we harvest, and then we till. Ah, we don't. Tilling turns it back to ground. So we say if get ground type equals grounds dot turf, then we till. Yeah, or what we actually say is not equal grounds dot soil. Yeah, that's better. Right, okay, so this... Whoops. This is plant carrots. Control tab doesn't work. Yeah, that works. So this is plant carrots. So now we say here elif number of items dot carrot is less than or equal to 300. Then do this. So if we now run this, now what we need to do is we need to add a check that says here if get ground type is not equal to grounds dot turf, then till, just to get back. And then same here. Okay, so we don't need trees. Can't unlock variables yet. Speed I can't unlock yet. How much wood do I need for any of these things? 350. So let's make you like 50. Ah, right. Okay, so you've not planted. If can harvest or get entity type not equal to entities dot carrots. So I need to just add that to here. And then you both need to check I don't know why it's... So you harvested that? If get ground type is not equal to ground.soil, then till it. Maybe we need to harvest and then till. Yeah, we needed to harvest and then till. So we need to harvest. I don't know why. Why did wood suddenly... Oh, because I bought some seeds. So there's some weirdness going on. If number of items is less than or equal to 50, then let's unlock. Let's unlock variables. Variables are unlocked. This is fine. So what's going on here? So let's get all the hay. Let's get the hay back. So this makes sense, right? If the ground is not equal to turf, maybe what I need to do is harvest and then till and then harvest and then till. So we're harvesting and we're tilling. Right. Now we're planting carrots, which makes sense. But occasionally we buy. So the weird one is occasionally we end up planting these. So hay is less than. Wood is less than. Carrots are less than, so we buy some carrot seeds. That's fine. Now we get the ground type. The ground type is not soil, so we harvest that. Then we till that. If we can harvest, or the entity type is not equal to carrots, then we harvest and plant carrots. Hay, wood, carrot seeds, we've got enough. Oh no, we needed to buy some. So the ground type is soil. So we harvest that, and then we till that. Plant some carrots. Is it the harvest here? So there's definitely a weird bug here. Hang on. We've got the carrots, so we step through here. Well, if get ground type is not equal to soil, if number of items of wood, is it because my wood? Maybe what I need to do here is till it. And then regardless, plant entities dot bush. But then what would happen is you would harvest everything. So if get ground type is not is grounds.turf, then we till it and we plant a bush. If we can harvest, regardless, the ground will now be turf. Now, if we can harvest, we'll harvest and then we'll plant a bush. Maybe that's it. Yeah, that's it. That's what's going on. Yeah, we're not getting random hay now. So let's expand the farm a bit further. So now we've got a 4x4. Can we unlock speed? Not quite. We can definitely unlock grass. Am I a magicsman? I was thinking about this earlier. I used to be. But wizards have really lost me. I've been seeing some of the Assassin's Creed cards for Universes Beyond or whatever it is, and it's just getting silly now. Like, sillier. But yeah, I've seen I saw the Lure preview earlier today. Which they certainly look like cards. I hope that answers your question. Right, we're tilling now. We've got 50 wood. And you know what I do here? Let's do get underscore world size multiplied get underscore world size squared, so that we always have 16 carrots. Uh, 16 seeds. So you need pumpkins. Now I can unlock functions. Oh, thank God. And one of them, the only one of them, has a typographical issue. Right. Now. Oh, thank God. Def. Traverse. So I can go here. Traverse grid. Then I can say plant. So let's replace this. Def plant underscore grass. I can replace you with plant underscore grass. Now plant bush. Def plant underscore bush. Plant. Common problem with Greek font display is the letters. Those two. I think one of those is pi, mu and pi. Because they're also using math, so unless you're careful, the text editors will use the Unicode signal for micro or pi. Yeah, when you do normal Greek letters. So so on the Cleopatra card, oh, that's painful. So one of the things I did when I was working for the bank is actually putting the app into Greece. I did a lot of work with internationalization, localization, and stuff like that. One of the languages we put it into was Greek, which was interesting to test because I can't read it. I don't speak it. Def carrots. Yeah, so that's gonna annoy quite a lot of people, I'm sure. That plant underscore carrots. Oh, that's so much nicer. This is so much better. Yeah, so on the Cleopatra card, the Empire, but the Socrates, they aren't. There's a couple of Greek topography oddities that are a lot of fun. Like the Sigma having 3 different forms, uppercase, lowercase, depending on whether it's the word or not. Yeah, I wonder if they've actually got any Greek localization. Anybody doing any Greek localization? It sounds like they probably haven't. They have a single word which is split with a comma in the middle of it. Oh. Def plant underscore all. Can I do named? I have to check something with Python. Let's have a look at variables. So I can set you that if I look at functions, unlike Python, functions defined in the global scope and no open file can be called by their name. Can I do named parameters? Python, I need to check this. Python functions named parameters. Quadratic a equal, yes, I can go a b c. I can pass in as keywords. So I can plant all, so I can say num underscore, so I can say hey wood carrot, and then what I can do is I can do this, hey, wood, carrot. And I can say plant all. Hay equals 300. Wood equals 50. And I can say carrot equals 100. Carrot. Okay, you can't do named variables in this. There we go. But that's good. That means my main is tiny now. I've just got someone to do the Greek translations because they look at the reasonable. Yeah. I wonder if it's print. It could be a printer thing as well. Like, oh, maybe. But someone will have sent them the art. Right, what's going on here? Oh, they cost hay. I didn't realize they cost hay. That's why that's why sometimes I'm getting hay coming out of this. So what utilities have we got? That needs pumpkins, watering trees. So actually, let's make you up to 200. Can we unlock pumpkins? Oh, you need like 1,000. And trees. Yeah, so I need 200 carrots. Maybe. Oh, the other thing I could do actually. I could say. I could say return false here. Otherwise, return true. So if you plant something, you return true. Out of curiosity, what languages are my usual go-tos? I assume you mean programming languages. I am a Java based dev. LF return. No, that wants to be else. I'm a Java based dev, so I will tend to go with a JVM language. So either Java or Kotlin is usually my go-to. But I can do JavaScript, TypeScript, Swift as well. Oh, right, an ad right there. Yeah, as I say, mostly a JVM language, so Java, Java, Kotlin, those sorts of languages. Swift, because I'm a mobile dev, so I write Android, iOS. Dart, if I'm doing for Flutter, obviously. TypeScript, JavaScript for React Native. Yeah, I can do Python. So what I've done here, I've just made the main. The main will stop. So this will return false if it falls all the way through this. Otherwise, it'll return true. In which case, the while will happen, and the while will just traverse the grid. So I'm just going to plant a load of wood. Have you made it? Have you made it through the ads? Did you hear my answer? Right. Okay. For the third, maybe fourth time. JVM languages are my usual go-to because I am an Android and I learned cut my teeth on Java, so Java, Kotlin, those sorts of languages. But I do Swift, TypeScript, Dart, Python, Perl if I'm feeling really painful. Right, you're not there for trees yet. So I could water. Plants grow faster. The growth speed on the plant grows linearly from 1 speed at water level 0 to 5 speed at water level 1. It dries up over time. You can use water tanks to water your plants. So the water loses 1% of its current water every now and then. Keeping the water level high would consume much more water than keeping it low. A tank can hold 0.25 water. Tanks fill up automatically. Fill rate is 0.5. So here, let's say, so we want to start watering the ground. Yeah, Perl if I'm feeling spicy. It's been a long time since I've done Perl. So let's start by getting the let's say get water. Def water. Let's say def water underscore ground. So what do I need to do? I need to check if have water. Buy water. Check ground water. Water ground. So let's see. So we check if num items dot water tank you can use water tanks to water your plants. You can purchase empty tanks with wood by trade empty tanks. A tank can hold. Do I just buy? So if you have 100 empty tanks, one of them will fill every 2 seconds. Is it what I... Do I just go... get underscore water. Get the current level water level on this drone. Yeah, so do I just go if the water is less than 0.5? then use items dot water tank. Yeah, do we just do that? And then def by_water tank num tanks, and then we say while get while num items dot empty tank plus items dot water tank. So I want to know the total number of so I want to know the total number of tanks. So I want to make sure if the is less than num, then trade items dot empty tank. So that'll buy an empty tank. So if I say buy water tank, let's say 10. Tanks fill up automatically. The fill rate is 0.5% of the number of empty tanks. So if you have 100, so if I say buy water tanks, so while the number of empty tanks plus, I think what I need to do is this. While the number of items... Oh, I haven't got enough wood. Yeah, you're right. I can't afford it. So, yeah, set this going again. How much is an empty tank? Yeah. So actually, what I want to do in plant all, at the end of the plant checker, before I move, I'll water the ground. And the other thing I could do is, if the get water is that and num items water tank is greater than 0, so it'll not bother. It'll not bother trying to how much do these cost? Well, items dot wood is greater than or equal to 5, and yeah, there we go. So if I haven't got enough wood, if I've got enough wood, I'll buy a tank. Otherwise, so what I can say now is buy water tank, let's say 100. So it'll buy water tanks up to 100 with the wood. Right, okay, what I'm gonna do now is I'm gonna say hay equals 300, wood equals 100, carrots equals 200, water equals 100. So, turning carrots off, yes. But carrots are the last thing in the list. So the order this goes is it will go hay, then it will go wood, then it will go carrots. Let's just stick you down there. So you can see that it's doing the wood first. And then if the wood got to 50, which it won't, because it'll buy more water with it. And to be honest, it's... to be honest, right? I don't actually care about watering the ground for anything apart from carrots. So I actually just take that off. And I only do that in the carrot one. Because by the time this gets round, these are fully grown. Yeah, there's it for the it only matters on the carrots, I think. You need like 1,000 carrots. You need pumpkins. You need 300. Needs like 100. So yeah, at the minute I'm only watering in carrots. Bushes and grass don't need to bother. I'm also wondering whether I can make the traversing more efficient. So snake traverse. Yeah, because that's what I'm thinking. So if we say current direction, and we start with north, and then we say if get underscore pos y equals get underscore world underscore size -1, then we say current direction equals south, but we move east, and then we move current direction, else move current direction. So let's just try. Let's just try this. So current direction is north, we move north. Y position is get world size, so we set our current direction to south, we move east, and then we move that way, and then we move we do it here, then we put the while true in there. I could move this out of the if. Yeah, because I've got this here. So I could do this anyway. So that does make things a little simpler. So now you're going to go south, and then you're going to go move east. So hang on. You go north. Yeah, so now what I need to say is else. Elif. So if we got to the bottom, then we say current direction equals north, and then we move east. So that then wraps us around. So current north-south direction is north, and then we say current east-west direction equals east. So what we do here is we say that, and then we say that, and then we say this. Possibly. There are some cases I think where you want to where it's okay to backtrack. This is just I've obviously got my regular backup, but yes, I agree. But there are some cases where you might want to do that, and it'll come up with pumpkins. So what we could do is we could keep 2 traverse methods, one for a snake traverse, and the other for a non-snake traverse. So if our get pos x is equal to 0, then current east-west direction equals east, else current underscore east-west underscore direction equals west. Move current if get pos x is equal to lf get underscore pos x is equal to get underscore world size -1 kind of works. I was expecting it to go back. Yeah, this doesn't quite do what I want. Because what I want to do... Can I do this? So instead, I do a snake traverse. You are... What was there was a thing about global variables. After a variable function dynamically typed and can be assigned like this, declare a variable A. With variables, it does nothing. Maybe it's under functions. The return functions are values just like any other. Unlike Python, functions defined in the global scope of the open file can be called by their name. Python. then. Would it be better to just have current direction equal direction and switch between it? Possibly. And that could well be a refactor that you could do. Because you potentially have two moves. So yeah, you potentially have two moves. Let's just while we do this, let's call this so we've got and then we can go while true. Let's just put this into a loop. Oops. Yeah, a list would be good, but lists are here. And dictionaries are here. I think the problem that I have. So if I go current underscore direction. So we start this as north. So we say if so let's say x equals get underscore position x, y equals get underscore position y, and we say size equals get underscore world underscore size. Right, so here we're getting we get our current position, and we're going north. So we say move current underscore direction. So regardless of what happens, we move in our current direction. Right. So if x is equal to 0, so if x is equal to 0, we're on this bottom row. We're on this bottom row. If x is equal to 0, then we're on the bottom row. And y is equal to 0. So we could do it like this. If we are in a corner, so if we're in that bottom left corner, then we set our direction to north. If x is equal to size, if x is equal to 0 and y is equal to size -1, then our current direction needs to be no, so I need to understand what my current direction is. the problem is, right, if I'm here and I'm going north, I'm going south, I want to change to going north. If I'm here and I'm going north, then I don't care. I need to sort of invert it. Oh, you are and not. Because if you're here, then we say go east. Then we say if... So that's this corner. So when we get to this corner, we start going north. When we get to this corner, we start going east. When we get to this corner, we... Yeah. Because otherwise we'll just end up going back and forth. Bouncing back and forth this way. That's why I had the east-west direction. I think what I'm going to do, I'm going to ignore that. And I'm just going to carry on traversing the grid. And I'm going to worry about it later. And I think there is something there, because you can pair your north-south. Because you kind of want to be able to go back on yourself. And you kind of want your... You kind of want to say, right, okay, if I'm in reverse, then east is west and west is... Yeah, that's kind of what you want to do. You want to say, go north, south, unless you're in reverse, in which case south is north, north is south. Something like that. I guess we ended up at some point with not enough wood. But we've got full set of hay there. Full set of water now. So we can't afford that. Pumpkins is 500 wood and 1,000 carrots. Trees is 50 and 200. That's what we're trying to get to. Can I do multi-trade? That's 300 carrots. Cool. So you're gonna get my carrots. We hit 300 hay again. Yeah, so the other thing you could do is you could create an array or a list with and you could, if you wrote your if you wrote this as a go-to, you could create a list that matches the snake, which could be kind of funny. You know what? I'll just upgrade the speed. Yeah, upgrading the speed makes this a lot better. Though if it was much quicker, it might be problematic. Yeah, so an array where you list every single coordinate in the path and just run through the array could be funny. But it doesn't expand to... As soon as you get a 5x5 grid, it goes a bit more difficult. So still need that. Still need 200 carrots for trees. Don't need the debugging. Bin max and absolute, that'll be helpful. But I kind of want to get trees unlocked. I think that's what I want. And let's turn hay to 500. Just to make sure we can get the grass upgrade unlocked. Because, yeah, I can basically increase the yield of grass. So grass will grow. So much quicker. You could have an array set up using the size of the field. There's only 3 cases to revert, no matter the size. Center, edge, or corner. Yeah. Something more like you can have an array, like a 2D array would also work. But I mean, you know, like whether you don't even need that because you know your position. And if one of the positions is 0 or max, then you're on an edge or a corner. So you don't need, you don't really need an array because you know where you are. You can always work out where you are. I wonder whether a spiral pattern... I wonder whether a spiral pattern works better. Where you spiral out because you can always turn right. But you might have to keep track of where you've just been. It probably doesn't actually matter. Because this is a toroid. So it probably doesn't actually care. But you could unwind, so you could unwind the spiral. So I was thinking, if you have an array, so if we have an array of directions, and our array is north, east, south, west. Then what I say is at some point, and then I could say directions. And then at some point I can say current direction plus plus. Oh, so we finished. Yeah, so you could say current direction plus plus, and then you're sort of essentially turning right. And then if you said minus minus, you're always turning left. So something like, yeah, plus plus is increment, minus minus. So plus equals 1 would work as well, or minus equals 1. Like something like that, because then you can keep looping through your. Every time you increment this, you're essentially turning right. So what have we unlocked here? I don't care about that. Let's unlock trees. Trees are a better way to get wood than bushes. They give 5 wood each. Unlike bushes, so trees like to have some space. Right, okay. Let's call this plant trees. So trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the north, south, east, north, east, west, or south of it. So if you plant trees on every tile, they'll take 16 times longer. So these need to be, yeah. So plus plus and plus equals 1 are the same, but you can do like plus equals 2, plus equals 3, and it's increment this thing by 3. Right. So plant trees. Plant underscore trees. So you need to be trees plant in a checkerboard. So how do you do this for so plant trees so we want to say, right, if yeah, you can take you can use the modulus in this. Okay, so plant trees. I need to plant these in a checkerboard. Delete that, delete that, delete that. Clear. Okay, so clear just sets me back to 0. Removes everything from the farm, moves the drone back to 0, 0, returns none. So I need to plant the trees in a checkerboard. So def check empty neighbors. So the way to check your neighbors is we move north and then we say if get entity type equals dot tree, turn false. Then we move south twice. So that resets us back to our original position. So hang on, let's say check in direction. And we say move in the direction. Then we want to move back. Hang on. All right, we say is underscore empty equals true. If the entity is empty equals false. Is empty is true. Is empty. So we say false here. And then we want to move in. I want to move in not the direction. And it's not how I can do it. And then our return is empty. If there's one thing I would add to this game graphically, it's including a tree structure of the code for your loop. Yeah. It'd be nice. There might be something under like debug or something else. Because I don't have everything unlocked. Oh, you haven't found it. So I want to check. I want to check the direction north. Check the direction south. Check the direction east. Check the direction west. And basically I want to and all these together. But I need to north, south, east, west. if I go north, east, south, west, and then I say move directions D, otherwise I move. No, even that's not good. I mean, the easiest way is to say go back. So here I say back, south, north, west, and I don't need this. So we move north, we move in the direction, we check if that's a tree. If it's empty, if it's a tree, then it's empty is false. We move back and we return is empty. And we check each of those. Then we say if check empty neighbors, then plant entities dot tree. So let's go plant underscore I don't think that quite did what I was after there. It's just let's just step through this. So plant trees, it's going to check for empty neighbors. It's going to check the north. So you're going to move north. Entity type equals tree. And then you're going to move back and return that that's empty. Otherwise, you're going to check south. See that that's empty. And then you're going to go back. And then you're going to go there. Right, so instead of planting bush, you're going to plant trees. And then we say if can harvest, then harvest. If we can harvest, then we harvest. Okay, so this is... so what arithmetic operations do I have? So plus, minus, multiply, divide. These guys. So you've got the modulo operator, you've got the power operator, you've got comparison operators. Obviously less than. You've got logic operators. So plant trees is not bad, but it could be better. Because I need to know. So if I'm on. So if. So we say x equals get position x. Y equals get position y. We say size equals get underscore world size. So we say if so we check if get position x and get position y modulo 2 is not equal to 1, move, else plant trees. I think I get what that's saying. Not equal to 0. X plus y modulus 2 not equal to 0. So if the x and y position, basically if it's an odd, if x plus y is even, is odd, then plant, I think is what you're saying. Let's increase the trees. I think... So if either of them are odd, I need to add them together like that. Just clear this. Whoops. Trees, sunflowers. I don't want to do sunflowers yet. I need... Right, hang on. Let's set wood to 500. Carrots to 1000. Yeah, it is that. And all that you do if you say not equal to 1 is you just move the checkerboard. So the 1 or the... So whether it's 1 or 0, it just shifts where the checkerboard is. And that gives me hay, and I think I'm all right just getting hay from that. So I don't actually need that, and I don't need that. So I need 1,000 carrots. Let's upgrade my carrots, so I get more carrots out of these. Yeah, we're getting carrots so much quicker. Upgrade my carrots again. Again, it doesn't matter. Because again, the grid size will just... I don't think it matters anyway. Because if it's a 5x5 grid, you'd be planting in... Yeah, you get fewer trees. So maybe... what you want to do is say size mod 2. No, I don't want size mod 2. I want size div 2. So we'll deal with pumpkins in a minute. We'll set this going. No, that's not right. Size mod 2. Size mod 2 always set in a 4x4. Should be that. There we go. So it will always do that. And normally, yes, there is a rounding function in Python. It'll be like floor or ceiling. I don't know if this has it. But we've got pumpkins. So let's grab our function here, and we'll call it plant pumpkins. So pumpkins grow like carrots on tilled soil. They require pumpkin seeds to be planted, which cost 1 carrot each. When all the pumpkins in the field are fully grown, they grow together to form a giant pumpkin. The yield of a giant pumpkin is the cubed side of the length of the pumpkin. So get pumpkins as big as possible before harvesting. 1 in 5 pumpkins die before they grow up. So even if you plant a pumpkin on every tile, one of the pumpkins may die and prevent the mega pumpkin. Okay. So the first thing to do is let's grab my plant carrots. And call this plant pumpkins. I presume I need pumpkin seeds. Yeah. Right. If the ground type is not soil, then that so we want pumpkins, say 1,000 pumpkins. Pumpkins here. My plant checker here is lf num items dot pumpkin less than or equal to pumpkin, then plant score. Plant pumpkins. And this is LF. All right, cache layer, graph. So you're going to plant pumpkins. Now, I want you to traverse the grid. I need you to traverse the grid. Because I need you to be able to check. So I want you to plant pumpkins. I want you to buy pumpkin seeds. So you've got 16 seeds. If the ground type is soil, then I want you to till it. If the get entity type is not equal to items.pumpkin, then I want you to plant. I want you to plant a pumpkin. Then I want you to traverse the grid. So you will items.pumpkin underscore seed. Items.pumpkin underscore seed. Plant. I can put. Oh, you need to plant entities. Dot pumpkin. Or I could keep planting. So I could say while get entity type is not equal to items.pumpkin, then harvest, and then plant. Then traverse the grid. Get entity type is not equal to items.pumpkin, or get entity type not equal to entities.pumpkin. Oh, there's a chance that you die before it grows up. Right, okay. So you die before it grows up? So that is a giant pumpkin. So it counts as a pumpkin, but then it dies after you moved off. So what I need to do. So as I traverse the grid, I want to count the number of pumpkins that I get. No, that only moves once. Yeah, because that only moves once. So you just move to the next. You just move to the next spot. Because at some point, I need to harvest this. I wonder if I can do this. I wonder if I can do this recursively. Let's call this. Right, this is our function plant pumpkins. This is our function plant pumpkin. So you're going to plant a single pumpkin. And then you're going to traverse the grid. And then we'll say pumpkins. Oh, but we're gonna need plenty of seeds as well. Well, number of items. Yeah. So we want to say while number of items dot pumpkin is less than num. Do this. And let's say 500. So you're going to keep traversing the grid. Right. If we So what I need to do is I need to traverse the grid checking for zeros. So what we're going to say here is empty spots equals true. Empty spots equals false. So if we are, if I get x is equal to 0 and get so if I get position x and I get position y are equal to 0, if empty spots is equal to false, then we harvest. So empty and not empty spots, then we harvest. Otherwise, we go through and traverse the grid. But what otherwise, if get entity type is not equal to items dot entities dot pumpkin. So this is the empty spot. Then we say empty spots equals true. Oh, this does need to be an if. And the reason this needs to be an if there are no empty spots, then harvest, because regardless, you say empty spots equal to false here. There we go. So this is not perfect, but it will scan and then it harvests. So we can say plant pumpkins, pumpkin. So let's put you over here. Sweet. So we're planting carrots. And we planted a bunch of trees. And pumpkins cost carrots, so we should always have plenty of carrots to buy the seeds. So pumpkin upgrade is 1.2. Multi-trade, sunflowers are 500. Fertilizer is 1,000. Lists 1,000. Let's expand the farm. Nice. So that's a much bigger pumpkin now. Can we upgrade multi-trade? Yeah, so we can buy multi-trade now. So instead of that, So what we do instead, let's stop that. And let's actually buy... Get world size to the power of 2. And in fact, let's say trade. I don't need a function for that because that function exists. I just need to use it. In fact, what I could do instead actually is write a function called buy seed. And then say if num items of the seed size equals get underscore world size. If num items is less than size 2, then trade seed size 2. And then here we just go buy items dot pumpkin seed. And then for carrots, we replace this with carrot seed. So we have a bunch of carrot seeds, and then we've got less than 25, and we buy 40 odd. And we're under 500 hay. So we could unlock... Sure. Nice. So we've got a nice big... And we could probably do with unlocking trees here. Yeah, if we do that. So the pumpkins are always gonna fully try and get one big pumpkin before it moves on. Which is fine. And then you're going to scan. I probably actually don't need this while loop here. I probably just need while... Rather than that, while empty spots is true. So if we go into this with empty spots, if empty spots, if no, we do that while, and then we say not need to harvest equals true, while need to harvest, and then we say need we just say while true. Yeah, we just say that. So you're going to plant hay. You're going to harvest pumpkins. You're going to harvest all that hay. So you're going to get to 500 there. Oh, you take no arguments? Yeah, so you are there. So you go through there, you plant all those, you plant that. Try and plant there, plant there. Then you check everything. And then you're going to hit those again. You're going to try and make sure you get that one big pumpkin. And if we were to, say, unlock speed a couple of times, then you go straight back to carrots. And then trees. Sweet. So I think we can do better with pumpkins. Because it goes all the way and it has to scan. So it's a little bit more awkward. So we can do better. We can do better with it. Can't afford that yet. So let's set these to 1,000. This to, let's set them all to 1,500. And let's set you to like 200. And what do we need to unlock more grass? 675. 1,000. Okay, we can get rid of that. Ooh, name scopes. Name scopes define... Scopes define which variables can be accessed from where, function differently than in Python. Just like Python has a global scope, each function has a local scope. Define a variable, defines a function. Variables from the global scope can be read anywhere, but when assigned, they will always go into the current scope. This prints 1, not 2. In Python, it's also possible to use a global keyword, not supported here. They use reference semantics. Global variable can store a reference to a dictionary that can read in a function. Yeah, so you would have to use a dictionary for global scopes, okay. It's a little bit funky. But not terrible. Not terrible. And we've got all our trees again. So we're planting the carrots. We'll get to 1,500 carrots. What's our yield of grass? 600. Let's have a look at what debug gets us. So we can assign breakpoints. We can use print. And we can use quick print. So we can use the output here. That's useful. Yeah, because we have to scan this again. So we can benchmark. No, can't unlock those. Not going to unlock sunflowers. Utilities cost 1,000. Lists, fertilizer. At some point, waiting for plants to grow. Use item fertilizer. Fertilizer can be bought with trade. So yeah, we could possibly use fertilizer to make pumpkins better. So that might work. So we'll have to try that next time. But for now, I think this is probably a good place to call it. So thanks for humoring me in the farmer. The farmer has returned. The farmer has been replaced. The farmer was replaced. Very neat little game. I like this. Useful for teaching you Python, or a similar thing to Python. So very cool, very cool. Anyway, that'll be me. Thanks for watching, folks.